This is the OCR foundation paper from 2018 in the summer. This is paper 1, which is, as I'm sure you'll know, the first one is a calculator paper. What I'm going to do is talk you through the solutions to them and how you do them. I'll spend a bit more time on some questions than others, and I hope this will be helpful for you. Question number 1. Here is a list of numbers. Write down from the list which is the odd number. I hope we're all pretty good at this. It's clearly number 5. Question 1A part 2. Write down the cube number. Cube numbers people get confused at. For example, I've put this here to show you that the answer is 8, but 2 cubed is always 2 times 2 times 2, which is 8. A lot of people will put 6 for this. It's a really easy mistake to make, so make sure you know your cube numbers. Part B, using the same list of numbers, work out the median. The median is a type of average. There's the median, mean, mode and the range, and the median is the middle number when they're in order. So here they are in order, and number 6 is the middle one. If there are 2 in the middle, so for example if I took the 12 out and there's only 4 numbers there, 5 and 6 would be in the middle, so the median would be between those two. So in this case it would be 5.5. But there's an odd number of numbers, so we've got a clear middle one, which is all good. The range is the biggest, take away the smallest. So in this case it is 12, take away 2, which gives you 10. Here are the first 4 terms of a sequence. What is the next term in the sequence? For this one here, it's not that tricky, but you've got a spot that is doubling each time. So double that, double that, double that, so double that, and you get 32. And how would you work out your answer? Key word here, explain. So don't just put times 2 or anything like that. Make a sentence out of it and show the examiner that you know how to write and how to explain yourself clearly, because that's a skill they're looking for in maths exams. All right, moving on. Question 3. Write 48 as a percentage of 200. 48 out of 200 looks like that. I've simplified it to 24 out of 100, and out of 100 literally means per cent. If you think in America they have dollars and cents. Well, cent is there because it means 100. Think of century and things like that. So yeah, 24 out of 100 is 24%. Work out a quarter of 80. A lot of you will just know to half it and half it again, which is fine. The answer is 20. But to find a quarter, you divide by 4. To find a third, you divide by 3. To find an eighth, you divide by 8. So that's how you do those. Part C, decrease 650 by 40%. There's lots of ways of doing this. It's a calculator paper, so if you're familiar with this method, that's the quick way of doing it. If you're not sure about it, ask your maths teacher, they'll take you through it. But this one here is a nice way of doing it. To get 40%, you can work out 10%, which is 65, because to find 10%, you divide by 10. So that means 40% will be 260, because there's 4 lots of 65. And because you're decreasing it, you're taking it away. So 650 take away 260 gives you 390. 3 relatively simple marks. There are lots of ways of doing it, but as always, make sure you show which one you're using. Question 4. Patrick writes down a number. He says, if I find the square root of that number and add 15, I get 27. So what number did he write down originally? Well, if he ends up with 27, but to get there he's added on 15, what I'm going to do is take away 15. So ends up with 12, and if he finds the square root of the number he's looking for, he gets 12. So what number, when you square root it, would give you 12? And the answer is 144. You can obviously go back and double check this, because you obviously square rooted it. You could then you could add on 15. It's worded in a bit of a strange way, but not too bad. Moving on, question 5. Write 12 to 54 as a ratio in its simplest terms. Well, there you go. I've shown how I've simplified it. In an exam, you should do this as well. Some of you with good times table knowledge would notice you could just divide both sides by 6 and you'll get straight to the answer, which is 2 to 9. 2 parts to 9 parts. The ratio 400 grams to 1 kilogram can be written in the form 1 to n. Find the value of n. So what this is on about is if you can get this number down to 1, what would this number be here? So again, show your workings because you'll get credit for doing things like this. So it's 400 to 1,000. I hope you can spot where that 1,000 comes from because it's 1 kilogram. And I hope you know kilo means 1,000. Think of kilogram, kilometre, that sort of thing. Or kilometre we say. But so what I've done, I've divided both sides by 100 to give me 4 to 10. Then divided both sides by 2 to give me 2 to 5. And because I want this to be 1, I've halved it. Then I half this side, so it's 1 to 2.5. So n would be 2.5 or 2.5 or 2.5. I mean, strictly speaking, you shouldn't have a ratio like this. We like to keep them as integers or whole numbers, but in this case it's absolutely fine. Next one, Amanda and Wim share some money in the ratio of 2 to 5. Wim receives £115. Calculate how much money was shared. So this is the way I always set these out. Amanda and Wim, because in the question it's Amanda and Wim, they share some money in the ratio of 2 to 5, so it's 2 to 5. And we're told that Wim gets £115, and we need to know how much money there was in total. So we need to find this figure out, then we need to add them together. So what I'm going to do is that I know that 5 parts is 115, because you can see it there because of how I've set it out. So that means 1 part must be 23, because I've divided it by 5. So if 1 part is 23, there are 7 parts altogether, so just do 23 times 7 is 161. Or you could do 2 lots of 23, which is 46, then add these 2 together, you still get 161. I'll say this a lot during this video, but show your full workings for it, please. Question 6. A leopard is running with a velocity of 3 meters a second. It then accelerates at 2 meters per second squared for 4 seconds. Use the formula to work out the final velocity of the leopard. Now, it's a little bit cheeky, this question, because it expects you to know that, well, v is velocity, u is what we call initial velocity. So that's the velocity it was running at. And you're told in the question that is 3 meters a second. A is the acceleration, which is 2 meters a second squared. And t is 4 seconds, because that's the time they accelerate for. You could probably work out that u was 3, because I think 2 and 4 are quite clearly these two here. So anyway, here we go. V equals u plus at, and at means a times t. I hope you're aware of that. So u is 3 plus at, which is 2 times 4. 2 times 4 is 8. 3 add 8 gives you 11, so it's 11 meters a second. Again, show your workings as much as you can. Question 7, here we go. Solve. Solve means find the value of the missing letter. It's usually x, but sometimes they change it. So 4x equals 56. So 4 times what is 56? I always like to solve these the way I'd solve an equation with unknowns on both sides. So we want to get the x on its own. So what is happening to the x? Well, it's being timesed by 4. How do you undo a times by 4? You divide by 4. And because it's an equation, you must do the same thing to both sides. So the answer is 14. And if you want to check that, 4 times 14 will give you 56. The next one's a little bit more fiddly, but I'll talk you through how I've done it, but there are other ways of doing this one. 126 divided by what equals 7? Now, you could have a guess at this. You've got a calculator, so it's going to be sort of a number between 10 and 20, I would have thought. So just try them until you get the answer 7 and put the answer there, because that will get you the marks, because it's only 1 mark. But the way I've done it is this. So I want to get the x on its own. So 126 divided by x is 7. I don't want this divide by x, it's a bit fiddly. So how do you undo a divide by x? You times both sides by x. So then I end up with this line here, 126 equals 7x. Divide both sides by 7. 126 divided by 7 will give you 18. Part 3 on that one. Again, solve it, 2 marks for this, so you should be showing your workings. You want to get x on its own, so the first thing we're going to do is to get rid of this negative 6. And we get rid of negative 6 by adding 6, so that will be 8x equals 52. Then we want to undo the times by 8, and we're going to do that by dividing by 8. So 52 divided by 8 is 6.5. So the answer there is 6.5, or 6.5 is fine. If you want to substitute that back in to check it, so 8 times 6.5, then take away 6, you can do that. Right, this next one, solved by factorising. It's a little bit cheeky to put this so early on in the paper, I suppose, but you've got to be able to, first of all, factorise this double bracket. We'll talk about the solving bit in a minute. So when you factorise it, it's a quadratic, so it's going to go into double brackets like this. You need two numbers that add up to make 11 and multiply to make 30, and those two numbers are 5 and 6. If you don't believe me, you can multiply out these double brackets and you'll get this at the top. Now that equals 0, so to solve this, one of the brackets has to equal 0, and the reason that is, if you multiply anything by 0, you get 0. So 38 times 0 is 0, 3 million times 0 is 0. So if this bracket, for example, was 0, it doesn't matter what this bracket is, because if you're timesing it by 0, the answer is going to be 0. So to make this bracket 0, x has got to be negative 5, or to make this bracket 0, x has got to be negative 6. So the answers to this question are minus 5 or minus 6 down there. But you might need to learn how to factorise into double brackets, because that can be quite a tricky skill, but I hope I've gone some way of helping. Next question. Question 8. This is the first one of the transformations questions we've got. Rotate triangle T, so rotate means turn it, through 180 degrees, so that's half a turn, around 0, 0. And 0, 0 is the origin there, that's right in the middle. So what I've already done it, you can see, but you'll need some tracing paper, and you lay that over the top like this. And apologies, this does not show up massively well, but I hope you can see it a little bit. So you sketch around the triangle, which is there, and you put your pencil in the middle to sort of hold it in place, and then you're going to turn your tracing paper through half a turn, and just watch that triangle disappear below my hands and come back out the other side, and that has gone through half a turn. If I went half a turn the other way, you'll see it should end up back in the same place. Because it's half a turn, it doesn't matter which way you turn it. Usually you'll be told clockwise or anti-clockwise, but in this case, because it's half a turn, it does not matter. 2 marks just for that. 2 marks we need to be getting. Next one, reflect triangle T, which is this one here, in the line x equals minus 1. So I just want to talk you through briefly where the line x equals minus 1 is, because a lot of people get this wrong. When you plot coordinates, you were taught at primary school and probably year 7 and year 8 and maybe even year 9, year 10, that you go along the corridor and then up the stairs. That's a nice easy way of saying you plot your x coordinate first, and then you plot your y coordinate. So when you plot coordinates, you're plotting them, you might not know it, like this, x and y, and then you put brackets around them, and that's a nice set of coordinates. You can plot points because you go along the corridor and up the stairs. Now it says here x is minus 1, so we're going to make up some coordinates. I'll do 3 of them, and in all of them x is going to be minus 1. Now you'll see why in a minute, but the values for y here don't really matter, but it'd be helpful if they stay between 5 and minus 5. So let's go for 4, 1 and minus 3, for example. Now if I plot these points here, you're going to see where the line x equals minus 1 goes. So let's plot them. Minus 1, 4, minus 1, 4, minus 1, 1 goes there, and the last one is minus 1, minus 3 goes down there. Now if I could have had -1, 2, -1, 3, -1, -2, and I hope you can see that they all go in a straight line. So I'm going to draw that line on, and then I'm going to label it x equals -1. There. Now you've got to reflect the triangle in this line. So there's a couple of ways of reflecting it. I'm going to show you with the tracing paper first of all, I suppose. You put that on. What I do is put a little cross at the end of each line, because reflecting is turning it over, and as long as I get my crosses to match up when I've turned it over, that will be alright. So get my crosses to match up. There you go. And there, you should just be able to see it there. It is going to go here, and because it's tracing paper, you should be able to do this, and you might need to go over it. There you go. I will just go over that to make sure it's clear. Sometimes they say label these triangles. I'm going to go back to the question in a minute to see if it wants them labelled. I don't remember them saying it, but sometimes they do. I'm just going to do that to make it nice and clear. Right, first one, label your triangle A. So this one is triangle A, so put an A in the middle. You can't see it massively well, but it's there. And the next one, label it B. There you go, B in the middle. So that is how you get 4 marks on that. Moving on, question 9. More transformations. 2 shapes are drawn on the grid below. Describe fully the single transformation which maps shape P onto shape Q. 3 marks, and here are where your marks are. You need to say it is an enlargement, or shape P has been enlarged. You need to recognise its scale factor 2, and the way you do that is it used to be 2 wide and now is 4 wide, so it is doubled. I did think for this question they might make the scale factor 2.5, because you could have squeezed it on just about. So if it was 2, that would have been 5. So you might have to spot that. But anyway, this is a nice easy one. And I've left this one blank at the minute because I haven't answered it. Around the point. So where has it been enlarged from? And this is how you do it. You get your ruler and you connect up sort of the corresponding parts of the shape. So I'm going to draw a straight line that connects those 2 up like that. I'm going to do the same thing with the other corners. So let's do these 2 top bits up here. So those 2 bits. There we go. And let's do 2 more. Let's choose this one and this one. You could do more if you wanted, but I think you're probably starting to see they're all going through the same point. So it is around the point 0, 0. And you will get the final mark for that. You could write around the origin. They'll give you the marks for that, but I think that's just a safer way of doing it. Next one, Ruben hires a car. It costs £150 plus 85 pence for each mile he travels. Right, so we've got details on the mileage here. I mean, when you read a question like this, I think it's fairly obvious, but I've been doing it for a while. You're going to have to work out how much he's going to pay for it. So that's how many miles it had done when he picked it up. Then when he handed it back, he did that many miles. Because they're referring to how much it is per each mile he travels, I'm going to work out how many miles he's driven. So I'm going to do 28,361, take away 27,612, which is 749 miles. You get 1 mark just for doing a basic subtraction, and it's a calculator paper, so it's very, very simple. You get an extra mark for working out how much it costs him just to drive those miles, and you're told up here it's 85p per mile. I've converted 85p into pounds, but you can convert it afterwards if you want. So that will mean that just on the miles he's driven, it is £636.65. Another mark for that. Show that you're adding on the £150, which I've done there, and the total is £786.55. You must show your workings for that. It is not enough just to put the answer. I know a lot of you do. You're very lucky your teachers might give you the correct mark, but if there's any mistake, however small, and you don't show your workings, you'll get no credit for any of that. Even if the examiner cannot read your answer, or the decimal point is very small and it hasn't shown up, you could lose marks. So do show your workings for it. It's not like a history or an English exam where we're asking you to write 2 or 3 pages of text. It's just your workings there. Question 11. Pippa owns a snack bar. Let's get that all on. She uses 3/5 of a kilogram of spread, like flora, each day. Spread, we use Bertolli at home, but Flora's other spreads are available. Spread costs £3.20 for 1 kilogram tub, or £6.15 for a 2 kilogram tub. She buys enough spread to last her for 14 days. What is the lowest price? Right, so what I'm going to do is work out how much spread, even before I get onto the money, how much spread she's going to use. So she uses 3/5 of a kilogram each day. So here we go, look, 3/5 of 1 kilogram is 0.6 kilograms, or 600 grams. Again, kilo means thousand, so you've got to be confident converting between grams and kilograms. 14 days, so 600 grams times 14 is 8,400 grams, or 8.4 kilograms. So that's how much spread she uses. You would have got 2 marks so far if you've got to this stage. Now we need to look at what's the best way of her to buy 8.4 kilograms. And the way I think it is by getting 4 2 kilogram tubs and 1 kilogram tub, because that will get you 9 tubs of it. So she'll have as much flora as she wants to last her a fortnight. It's all rock and roll in the sandwich industry. So what you do, 4 lots of 2 kilograms was 4 lots of £6.15, because it's up there. Then you want 1 lot of the £3.20. You don't need to show your workings for that, but I've done it just to help out maybe. Then you add up those, and there's your final answer, £27.80. She is the cheapest she can buy the spread for. Do read the question, because it says what is the lowest price she can buy the spread for. So don't go 8.4 kilograms and think, oh, I'll just buy 9 lots of 1 kilogram tub and that'll do. Try and think a little bit real world about it. You wouldn't do that in the real world. You would try and get it as cheaply as you can. Still on Pippa, part B in this question is how much she paid on rent. So she paid £1,650. I'm not sure if this is for a sandwich shop or for home, but very cheap home if it is. In 2017, the rent increased by 14%. So look, there's another percentage question there, and it's increasing, so you must know how to do it. Calculate the amount of rent she paid in 2017. If you're confident with percentage, here's your quick way of doing it there. Converting the 14% to a decimal, and because you're increasing, you add it on to 1. So that's your multiplier. If you're not confident doing that way, you can do it this way. 10% is £165, so 1% is £16.50. Use your calculator. 14% rather, is £231, and then you add it on. So 1,881. Again, show your workings. Question number 12. A circle has a radius of 6 centimetres. I've drawn that, and I really suggest you draw that. Because it will start ringing bells in your head with what you did in class. So it's got a radius of 6 centimetres. There we go. Calculate its circumference. And as you will all know, circumference is pi times the diameter. 6 centimetres is the radius. The diameter is double the radius, and it goes all the way across the middle. So on this circle, the diameter would be 12 centimetres. So you've got to do pi times 12. Which is 37.6991184. I really suggest you write down that full number, because once you've done that, you've got 2 marks. Then you get your additional mark for rounding it to 1 decimal place, which is 37.7. When I mark these, a lot of students put down as a final answer 37.6. because they just did it on their calculator. None of these workings, and obviously they got 0 marks for it. So do all that, because at least if you make a rounding error, you'll still get 2 marks up there. Question 13. Show that the highest common factor of 18 and 63 is 9. There's 2 ways of doing this. Well, there's lots of ways, but these are the 2 that I want to talk about. Now, the mark scheme says you will get the 2 marks for it if you correctly list all the factors of 18 and all the factors of 63, which I believe I've done here. Don't think I've missed any out. And then you can clearly show that 9 is common in both, and it is the highest one, hence it is the highest common factor. The other way of doing it, and this will help you with the next part of it, is to draw a factor tree for each of the numbers, which you can see I've done there, and then put the prime factors at the bottom into a Venn diagram. So you've got a couple of 3's this side and a couple of 3's that side, so they both go in the middle. Left over here you've got a 2, so that goes there, and the other side you've got a 7, so that goes there. And the highest common factor are these 2 numbers in the middle multiplied together. So 3 times 3 is 9. Either method, you will get your 2 marks for it. The next one, find the lowest common multiple of 18 and 63. If you need reminding about what a multiple is, it's in the times table. This is the simplest way of doing it. I've just done my 18 times table and my 63 times table, and you can see the answer is 126. That will get you the 2 marks. If you have used a Venn diagram, to find the lowest common multiple, you simply multiply all the numbers inside it together, and that gives you 126 as well. So either way is fine. Next one. I'll just zoom in on the question. This is a bit of a fiddly one. Aditi, Becky and Callie collect coins. Aditi has 6 more coins than Becky. Callie has 1 less coin than Aditi, and altogether they have 71 coins. How many coins do they each have? Show your workings. You can have a bit of a play around with the numbers here if you've got time at the end and try and make not an educated guess, but use a bit of trial and error. But it's 5 marks, and this is the way I would do it. I've written their names up the top, and I've called Becky X. That's how many coins she's got. And the reason I've done that is because it says Aditi has 6 more coins than Becky, so that means they've got X had 6. And Callie has 1 less coin than Aditi, so that's how many Aditi had. So Callie's got 1 less than that, so she's got X had 5. So because you know there's 71 altogether, that add that will equal 71. I've simplified this to 1, 2, 3x, add 6, add 5, which is add 11, gives you 71, and I've solved it. So I've subtracted 11 from both sides, and then I've divided both sides by 3. So x is 20, so Becky has 20, Aditi's got 26, and Callie has got 25. There are other ways of doing that without using the algebra. You could use a bit of trial and error, but I think that's the way thereafter. But you get the answers right, you'll get the marks right. Question 15. Lee wishes to find out if there's a relationship between a person's age and the time it takes them to complete a puzzle. So Lee decides to conduct an experiment. She asks 10 people to complete a puzzle. 12 people to complete the puzzle. She records each person's age and the time taken to complete the puzzle. So we get the idea of what she's doing. It sounds fairly straightforward. We don't know what the puzzle is. I don't think it matters too much. Make 1 criticism of Lee's method. Well, when I was reading it, the first thing I thought was if you're going to get any meaningful data, you certainly need to ask more than 12 people. So I would suggest one answer is, because it's only 1 mark, you only need to put down 1 thing. The sample size is certainly too small. Whenever you're doing any research like this, you need to say how you're selecting the participants for it. I'll just give you a really silly example. Let's say Lee's mum worked as a university professor, and let's say they're all old and above 60 or 70, and she gave them the puzzle to do. chances are they would probably do the puzzle quite quickly, depending what the puzzle was, than maybe someone who's in a retirement home who's been retired for some time but is of a similar age. So it is important to know how they chose the people. So Lee does not say if the participants have been randomly selected. But anyway, sample size is too small is your easy one for that. Right, so that's 1 mark. The next mark are possibly the two easiest on the paper. Plot these on the scatter graph. So 47 and 21. 47 and 21 is there. 60 and 34. The age is 60 and 34 is there. I still cannot believe it's 2 marks for plotting those 2 points. But anyway, happy days it is. What type of correlation is shown in the scatter diagram? Right, you need to be aware of this. I've done a little diagram here. If your scatter diagram looks like that, it's a positive correlation, and you remember that because it's going up. If it looks like this, it's a negative correlation, and it's because it's going down. And if they're all over the shop with nothing really going on, it's no correlation. So let's have a look at our scatter graph. I think it's fair to say they're going up, so I'd suggest that is a positive correlation. So what type of correlation is shown by the scatter diagram? A positive one. We're going to come back to this diagram in a moment, but I want to show you the next question. Estimate the time it would take a person aged 35 to complete the puzzle. Show your workings to justify your answer. What that means is, on a scatter graph, in maths at least, you can draw something called a line of best fit. And a line of best fit is quite simply a line that fits the best. So you get your ruler, and you want to have roughly the same number of crosses either side, and your line has to follow the general trend. So it's got to be something like this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we do it like this and try and get 6 each side. 1, 2, 3, 4, 5. That'll do. Something like that would be fine. There's, obviously there's a wrong answer to that, but it could be slightly out. That is fine. The question said, estimate how long it takes someone who is 35 to complete the puzzle. These are the workings you must show. So you've got to do this. You get your ruler, find 35 in the age, you draw the line going up. Again, you must do this, otherwise you won't get the marks. And then when you hit the line, you come across, and this is going to tell us how long we think it would take them to do the puzzle. And in this case, it is 11 minutes. Just leave that there for you to look at. When you get a scatter graph question, if it's asking you to use it to estimate something, you must draw these lines on it. You won't get the marks if you don't. So we said that was 11 minutes. 11 minutes. You might get a different answer to me because your line of best fit might be slightly different. And if it was, you might have got 12 minutes, maybe 10 minutes. That's fine, it doesn't matter as long as you're given the answer that your scatter graph says. So if I'd done this, then I wrote 12 minutes, I would have lost a mark for it because I'm not reading my own diagram correctly. Lee says that at least 80% of the 12 people completed the puzzle in under 30 seconds. Is she correct? Show your workings. So 9 out of the 12 people completed the puzzle in under 30 seconds, and you know that because you can look at your graph here. 30 seconds, that's the line there. So there's 3 above it, so 3 took longer than 30 seconds. So using maths, 9's below it because there's 12 in total. So 9 out of the 12 completed it in under 30 seconds. You can use your calculator for this, or you might know how to do it, which is 75%. So Lee is wrong, as only 75% of the people completed the puzzle in under 30 seconds. Look, 3 marks for that. So make sure you're explaining it really clearly. Show your workings. There we go. Look, show workings to support your answer. You cannot put "is Lee correct" and put "no" and expect to get any marks for it at all. You will not. You must show workings to support your answer. Question 16. Finn has 2 bags of counters. He takes a counter at random from each bag. The probability he takes a red counter from the first bag is 0.3, and the probability he takes a red counter from the second bag is 0.4. What is the probability he takes at least one red counter? The easiest way of doing this, I think, is with a probability tree, which you can see I've done here. Let's just explain it. So this bit, let's get rid of that. So this is your first bag. The probability he takes a red counter is 0.3. That means the probability he doesn't take a red counter is 0.7. So when you're in real life, you're actually going along one of these lines here. Your second bag, it says probability he takes a red one is 0.4. So it's 0.4 to take a red. So that must be 0.6 not to take a red, because they must add up to 1. And the same thing down here as well. Now, when you're using a probability tree, you have to work across it. So, for example, if he takes out a red from the first one and a red from the second one, the probability of that is 0.3 multiplied by 0.4, which will give you 0.12. The probability of you taking not a red and not a red is 0.7 times 0.6, which is 0.42. You must show your workings. All of these numbers here, incidentally, would add up to 1. And on a probability scale of 0 to 1, 0 being impossible and 1 is certain. So one of these outcomes here must happen. Now the question says, what's the probability he takes at least one red counter? Well, from this one he's taken 2, so yeah, we'll have that. From this one he's taken 1 red counter, because he took a red one first, so we'll have that. This one here, not red but red, yes, so we'll have that one as well. And on the bottom one, no reds there at all, so I don't want that. So I've added up those 3, and you see my answer is 0.58. Question 17. The price of a computer was £700. In a sale, the price is reduced by 20%, and you see me doing that there, because 10% is of 750 is 75, so 20% is 150. So I've subtracted it. Happy days there. On the final day, the sale price, and this is the sale price here, £600. That is reduced by a further 12%. So we have to reduce £600 by 12%, and you see I've done that here. 10% is 60, 1% is 6, so 12% would be 72. So you subtract that away from it. So this is the final price of the computer. Now the question asks for how much is saved in total by buying the computer on the final day of the sale. Well, that's how much it did cost to start with, and you take away how much it now costs, so you are saving £222. That is a 5-mark question, and it's, again, percentages. They've cropped up yet again. So get good at percentages, because that is 5 marks. If you read the question carefully, you should be having. Again, show your workings for it. It's very unlikely, in fact it never happens, you get a 5-mark question where you can just put an answer down and expect to get credit for it. You have to be showing your calculations. Question 18. This is the mean of grouped data. If you haven't done this, go and ask your teacher. I'm just going to explain what I've done. I'm not going to explain how it works. But the table below shows the weight in kilograms of bags that people took on a plane. So that means 16 people took on a bag that weighed between 0 and 10 kilograms. 10 people took on a bag that weighed over 10 but up to 15 kilograms. And I think you get the idea. They could ask you questions like, what was the modal weight of the bag? So that means what's the most common frequency, which is, so 20 people. So the modal class width would be over 15 and up to 20 kilograms. Anyway, I don't know why I said that, because it's not asked that question. Calculate an estimate for the mean weight. Right, the mean is when you add them all up and divide. But the trouble here is it's all in a table, so we've got to do something slightly different. We don't know how much these 16 bags weigh exactly. So what I'm going to do is pick the midpoint of 0 and 10. This is where the estimate bit comes in, because we're estimating that these 16 bags all weigh 5 kilograms. I'm going to estimate all these weigh 12.5, and all these weigh 17.5, and so on. So I've got 16 bags. They probably all weigh about 5 kilograms each, or certainly average out to. Then I've got 10 bags that weigh 12.5 kilograms each, 20 that weigh 17.5 kilograms. So I hope you can see here that I'm actually multiplying across, and then you get the answer over here. And it's the mean average, so you add them all up, which is 900, and you divide by how many you had to begin with, and there are 60 bags because I've added up the frequency. So an estimate for the mean weight of the 60 bags is 900 divided by 60, which is 15 kilograms. And I put it down there as well, but 15 kilograms. Again, you've got to show those workings. If you haven't seen that before, please ask your maths teacher. Right, question 19. The scale diagram below shows two cities, P and Q. A plane departs P at 9:47 and arrives at Q at 12:07. Work out the average speed in kilometres per hour of the plane. It's a bit of a fiddly one, this, because it's worth 5 marks. So I'm going to take you through what you've got to do. The formula you need to be aware of for speed, distance, time can be shown in this triangle: speed, distance and time. You would have seen this in your science lessons, I would have thought. And using this, you can say, well, the formula for speed is distance divided by time, the formula for time is distance divided by speed, and the formula for distance is speed times time. Right, we're trying to work out the average speed. First off, I know when it took off, I know when it landed, so I'm going to work out how long the flight took. So it's a bit fiddly, this, you can't just subtract it. So what I'm going to do is 9:47, and the next, that's AM, and the next nice sort of time is 10 AM. And that is 13 minutes. So 13 minutes, write that in there. Got to go up to 12:07, so let's go to 12 midday. And going from there to there is 2 hours. I hope you can see my sort of method behind this. And the last one is 12:07, and obviously that is going up by 7 minutes. So the travel time is 2 hours and 13 add 7, 2 hours 20 minutes. There you go. You get at least 1, maybe 2 marks just for doing that. Now we need to work out the distance. We've got a lovely scale up here, so let's get another mark by using our ruler. The distance here is, and I'll try and do this as accurately as I can, is I make that 11 centimetres. It's actually 11.1. Now that could be because of the photocopying, but I'm going to assume that is 11.1 centimetres. So what I might do is actually draw a line between them and label it 11.1 centimetres. So the examiner knows what I am working from. Now, you've got a scale here. 1 centimetre is 125 kilometres. So what I'm going to do is use my calculator. Hello, not seen you for a while. So we're going to do 11.1 multiplied by 125, and this will give us the distance in kilometres. So it is 1,387.5. 1,387.5 kilometres. So I'm going to write that down here as well. So the distance is 1,387.5 kilometres. Lovely. Now we can start using our formula. So speed is distance divided by time. So make sure you show exactly what you're doing for this. So speed equals the distance, 1,387.5, divided by the time. A lot of people for the time would put 2.2, and I think we can see why, because 2 hours 20 minutes. I mean, it's wrong, but we can see why they've done it. Obviously it's 2 whole hours, But you need to work out how much of an hour is 20 minutes. And half an hour is 30 minutes, 15 minutes is quarter of an hour. So I hope you can see that 3 20s go into an hour. So it's actually 2 1/3 hours. And you must use 2 1/3. If you're good with your calculator, you can use 2.3 recurring. That is also fine as well. So let's do that calculation. So there we go, and we're going to divide that by 2 1/3. So I'll put it in again. 1387.5 divided by, I'm going to use my fraction button here, 2 and 1/3, and hopefully this should give us the correct answer, which is 594.6 kilometers per hour. We could just put kmph, it doesn't matter too much. So that's how you do that. Again, I apologise if it was 11 centimetres up the top and I've mismeasured it, then it would change the distance a bit. But look, as long as you're showing what you've done, they'll give you the marks for it. Okay? Next one, give one reason why your answer may be inaccurate. There's 2 reasons. The plane might not have flown in a straight line. So if the plane has had to fly, maybe done an arc around something, maybe it was trying to avoid another airport or something, it's actually travelling faster then because it would have covered more distance in the same time. And linked to that, the plane may have been diverted somewhere else. So again, that means it's very unlikely that plane flew straight across that line. They might have gone up here for a bit and flown across there, then come back down. Who knows? But anyway, so it might not have flown in a straight line. Question 20. The scale diagram below shows towns A, B and C. The line AB represents the road from A to B, and the line AC represents the road from A to C. A shopping centre is to be built so that it is nearer to the road AB, so nearer to this road here than it is to that road there. And it has to be less than 14 kilometres from here. So it's already done, but I'll go over it again to show you what I did. To find the line or the area that is closer to this line than it is to this line down here, you have to do what we call bisecting the angle. And I'm going to show you how you bisect an angle. First of all, you'll need one of these. If you don't have a decent one, please make sure you get a decent one. Don't just take one from a maths room, because chances are it's been left there because it doesn't work very well. This one here, you can probably see, is a little bit wobbly, and they should be a lot firmer than this. But anyway, we'll do our best. So what I did was, you put your point on A there, and you get your compass. Doesn't matter how big it is, I'm just adjusting it to the size I had it. You do a little swipe there, and I hope you can see the line, and you do the same thing down there, another little swipe there, you can just about see the line. Then what you do is put your point there, and you do this line which is swiping down here. Hope you can see where that would have gone, not quite as clear, but there you go. And you do the same thing for the other one, and you can see the line I've done there, just about. If you zoom in, you can see it. Now, you then take your ruler and you connect up where these 2 points cross with point A. So that's what I've done, and I've drawn a line, as you can see there. So that means anything in this section up here is closer to the line AB than it is to the line AC. So this is the area we're interested in. So it's going to be built in here somewhere. Now the next bit, it says it's going to be within 14, less than 14 kilometres from C. So it's going to be within 14 kilometres from C. Now you've got a scale here. 1 centimetre is 2 kilometres. So you want to know how many centimetres is 14 kilometres. Well, you times that by 7, so you just simply times that by 7 as well. So then what you do to find out how far that is away from C is you get your ruler out and you put this to 7 centimetres. So I want to do it a little bit more. There you go. That is roughly 7 centimetres. Oh, there you go. It's probably a bit, something like that. As long as you get it roughly right, you'll be okay. So you keep it that length, and then you put your point on point C, like that, and then you can see this arc I've drawn around here. So all the points on this line I'm drawing are 14 kilometers from point C. Now, it says shade in the region where it could be. Well, we just discussed it's got to be above this line. That's the angle we've bisected. And it's got to be within this circle bit we're drawing here. So that means this here that I've shaded in is the only place you could build it. Now, part B says, explain why the region found in part A, so this bit here, might not be suitable. Now, as long as you put something sensible, you could say anything really. You could say this region here might be a big lake. You could say, so obviously it's not a good place for a shopping centre on a lake. You could say it's a graveyard, and that wouldn't be very nice to build it on a graveyard. There could be people's houses here. You don't want to do that. You could say we've gone for a no-deal Brexit. No one has any money left to go shopping with. No, don't say that, but you sort of get the idea. Another couple of answers are that these lines here just represent roads. They're not actually the roads. So these roads might not be straight. And also it says road. Well, if that's a little country lane and that might be a motorway, then you might want to think about having it nearer up here than you do in the middle of them. Anyway, as long as you put something sensible, you'll be okay. Question 21, and this is the last question on the paper. Now, this is probably the hardest question I've ever seen in doing this job for about 10 years on a foundation exam paper. If you're looking at getting a grade 4, or even a 3 or a 4, you might want to just end the video now, I'll be honest with you. But I will talk you through how to do it, but it's really, really nasty. So what I've done, well, actually, that's not fair. You can pick some marks up for this. So you've got a bit of some algebraic expressions around the outside, and it says the dimension in centimetres of this rectangle are shown below. Work out the width and the length of the rectangle. So work out that length there and that length there. Well, I looked at this and I wasn't sure what it wanted. So I started off with saying that this length here is the same as this length here, because it's a rectangle, as it says up there, so those two are equal to each other. So that means that which is that bit there, is equal to that which is there. Then what I've done is I've rearranged it, because I've now worked out we're going to do the same thing for these two. So put that is equal to that, there it is, and we're going to use this by using simultaneous equations. So you need to have it sorted out that your x's and y's go on one side and the number goes on the other. So you can see what I've done here. Well, I hope you can. So on this side you're left with x plus 7y equals 1, and when you do the same thing here, you've got 2x minus 6y equals 12. You can pause this if you want to have a good look through my workings for it. Down here I've set up my simultaneous equation. I'm going to zoom in on that. That's the answer I got from the first bit there, and this bit here comes from over there. And when you solve a simultaneous equation, you've got to get either the x's or the y's to be the same. Now I've chosen to get my x's to be the same, because to do that all I need to do is double everything on this top row. So that's going to become 2x plus 14y equals 2. As you can see, I've written that there. So if you wanted, you could almost put a line through that now, because you don't need it. Right, so you've got 2x and 2x. How are you going to make that 0? Well, you're going to subtract them. So you need to subtract everything. So 2x, take away 2x is nothing. Minus 6y, take away 14y is minus 20y. And 12, take away 2 is obviously 10. So that means y must be minus 0.5 or minus a half, because minus, if you want, you could flip these round so it's 20y equals minus 10, which might make a little bit more sense. I'll write that down. 20y equals minus 10. Let's make sure that's a 2. So solving that, y is minus 0.5. Now, if you know y is minus 0.5, all you've got to do, and I say all you've got to do as if it's really easy, but all you've got to do is substitute in this value to any one of these things here. So I'm probably going to choose this one because I know that 6 lots of that is going to give me a whole number. So, although it is negative, so I'm probably asking for trouble. But anyway, so 6 lots of minus 0.5 would be minus 3. So you've got something, take away minus 3, which is going to give you 12. So that, when you're taking away a minus, don't forget that makes an add. So something add 3 equals 12. So that would be 9 add 3 equals 12. So 2x is 9, so 1x must just be 4.5. I told you this was tricky. Once you've done that, we haven't finished yet, you've got your value for y and your value for x, and you need to substitute them into this length here and this length here, because that will then give you the length and the width of the rectangle. I don't know if you want me to go through it because it's just a little bit fiddly, but you've got your y and your x values, substitute them in to say that one, because it looks quite nice and straightforward, and it will give you the width or the length. I think I said that one was the width and that one was the length. But anyway, there's how you do that one. Like I say, don't worry too much about that last question. It was ridiculously hard for a foundation paper. Right, so there you go. It's out of 100. If you're looking to get a grade 4, you need to be getting at least half marks. I think from the top of my head on this one it was 53. And some of you might be worried, thinking, oh god, that's quite high, I only got in the 20s or 30s. Keep trying hard at it. Go through this exam paper, because when you go through the questions, I mean, don't go through every question I've done. Go through the questions you got wrong, and hopefully you'll go, oh yeah, I remember how to do that because I have been taught it before, and then you'll get it right next time. If there is a question that you haven't got a clue about, probably excluding this last one, but if there is one you haven't got a clue about, please go and ask your maths teacher during a lesson or a revision session, and I'm sure they'll be very, very happy to help you. Thank you for watching. I'll get paper 2 and paper 3 uploaded very shortly.